let's take a look at how we can define the number and distribution of our fragments. With our Voronoi fracture object selected, let's go to the attributes and click on the sources. Now in the sources, you will see that we have this sources list. Now let me click on the point generator distribution. This is the default state. And you will see that we have a host of parameters underneath. What happens is that this point generator, which generates a distribution of points, and this is the icon for the distribution, this is the activate, deactivate of the particular point generator, and this is the visibility in the viewport of the points. You can see the green points off and on. What this does is create a number of seed points which define the centers of each fragment. Now you can see that it has a name, and if I change the name to hello, the name will reflect over here. You don't have to name it hello, by the way. Just saying. So what we have here is the distribution type. Before I move to this, the point amount, which is quite simple to understand. If I put 200 points, I'm going to have more points, therefore smaller fragments. And the seed means a different random value. So this particular number doesn't mean anything in particular, it's just a different number from this, for example. Anyway, let's go to the distribution types. Uniform tries to uniformly lay points inside the object volume. If I go to normal, this has a bias towards the center of the volume. And if I decrease the deviation, the bias becomes bigger, and if I increase it, we go to a normal distribution mode, a uniform distribution mode. If I change this to inverse normal, you will see that the bias goes in the inverse position of the previous one. So we get the points concentrating at the edges of our volume. And if I go to exponential, then we have this new little menu underneath here. And this means that our distribution is going to be defined by this. So now we have this x-axis affection, which means that we are going to have a distribution more so on the plus x or the minus x, plus y or minus y, plus z or minus z, or none of the above. But you can see that this way we can distribute the points exactly in the position we want to. Now we will see later on that we have other ways of creating these distributions in more interactive ways, but this is a fantastic way to go and concentrate your fragments in one particular part of your volume. And again, deviation changes how much the bias is. And let's go back to our uniform and continue. So before I talk about the inside high quality and create points per object, let's look at the transformation. Look at these green little lines. This is a volume bounding box. If I move this, you will see that the volume moves out. But the points are only generated inside our object. That's why this inside is checked. If I uncheck it, now you will see the points being distributed outside as well. So inside is the default. And of course I can do things like scale it, or rotate it, or anything I need in order to get the points exactly where I want them. Now create points per object. What does that mean? Well, let me zero out all these things. Excellent. And what I'm going to do is go to the cube and command drag to make a copy, drag it over here, and now I have two cubes under the same Voronoi fracture, which means that both cubes are going to be fractured. Let me select this, and with a point generator distribution hello selected, we have point amount 200, but this is 200 over 2 objects. If I had more than 2 objects, then the 200 will be over the 4 or 5 objects I have selected. So let me go and do this, and let me make another copy, and now let's click on this. Now we have 200 points over 4 objects. But if I want to have 200 points per object, then all I have to do is activate the create points per object. And there you we have it. In order to show you how high quality works, I have this very simple 2-polygon whatever's left over cube. So we just have these 2 polygons here, 1, 2. Excellent. Now by default, you can see that the distribution happens within a volume, which is defined pretty much by the boundaries of this little shape. Now this is okay, but it's not the best way to define a volume from these 2 polygons. In this case, if I click on high quality, you will see that the distribution of points is closer to the 2 polygons here. And if I increase the number, you will see the difference. So I'm going to go around here, and you can see that now the points are closer to the polygons, contrary to this where they're scattered everywhere. So this is a more accurate algorithm, albeit a bit slower. I haven't tested it with huge amounts of points, but it's in theory slower. You'll find out as you try out these attributes. And basically, this is what the high quality does. Now that we know how to control the default point distribution attributes of the Voronoi fracture, let's move on and see how we can use more ways to generate and control our fragments.